nano VNA tracing showed SWR of 1.213 at 14.680 MHz for a 20 meter center-fed dipole antenna. That was quite above the 20 meter amateur radio band. I wish to make it resonate for 14.075 MHz. How to proceed? A simple way is to find the wavelength for 14.680 MHz, which comes to 20.42 meter. Next, I calculated the wavelength for 14.075 MHz, which comes to 21.30 meter. For simplicity of calculation, I did not take into account the velocity factor of the material of the antenna wire. So the difference in wavelength is 88 cm. 1/4 of it will be 22 cm. Each side of the antenna will have to be lengthened by 22 cm. But the antenna is already mounted high up with difficulty in accessing one side, while the other side is easily accessible. I thought of adding 44 cm to one side which was easily accessible. As a simple method, I am just hanging down the 44 cm of wire joined to one end and checking the response. Disadvantage expected is that the antenna will become slightly off center fed than exactly center fed. Even though it was slightly off center fed as per my calculation, the response was excellent. SWR dip was 1.271 at 14.140 MHz on the nano VNA tracing. That is well within the 20 meter amateur radio band. Tested in my FT710 radio, and I was happy to see SWR nearly 1 on 14.140 MHz. I have noted this slight disparity between nano VNA and radio always, but that is quite in the acceptable error range. Similarly, low SWR was noted on 14.075 MHz, the originally intended frequency. Even though I had not taken into account the velocity factor and not lengthened the antenna equally on both sides, the end result is a successful antenna tuning challenge. It is possible that the antenna elements were not exactly equal on both sides earlier. In that case, asymmetric lengthening on one side could bring down the SWR as well if it had fortuitously equalized the lengths on both sides.